All right, we just said memorize these earlier, but you know what? Let's take an opportunity here and prove one of them, because it's nice to have that proof just to see where it comes from, right? So we're going to prove the derivative of tangent x using sine and cosine. So y is equal to tangent of x. And if we use our ratio identity, we know this is the same thing as sine over cosine. With sine over cosine, that's the quotient rule. Okay, so let's do it. And you'll see why we just memorize it, so we don't have to figure this out every time. But it's good to know. So the derivative of the top, so the derivative of sine is cosine, times the bottom, plus the top, times the derivative of the bottom. We know the derivative of a co is negative, all over the bottom squared, right? Okay, let's clean this up a little bit. I have, oops. Why I made that a plus is beyond me. It's minus. You guys are probably hollering at me. I'm so proud of you. All right, so a negative times a negative up here is going to give me that positive. I think my brain just did it before my hand did. So I've got cosine squared plus sine squared over cosine squared of x. Now, you cannot go through and simplify these, right? You can't cross off those cosine squareds because it's touching that plus sign. But what do we know? Think about your Pythagorean identities. What's sine squared plus cosine squared? Oh. Huh? Do you see what's just happening there? If we use this Pythagorean identity, then I can replace sine squared plus cosine squared with a 1. 1 over cosine squared. And what's the reciprocal identity of cosine? Yes, it is. Secant squared x. So we know, because we're awesome and we're learning this stuff, the derivative of tangent is secant squared. And we just proved it. All right? Okay. You can prove all the rest of them too. We're not going to take the time to do that in class, but you are welcome to look that up and see those proofs, because honestly, it's really pretty cool just how you manipulate those identities and work them through. But we're going to look here at example 4. Just practice derivatives. That's what we're going to finish our lesson out with today. Practice these derivatives. So find the derivative. There's just one to this problem. Y is equal to secant x cosecant x. So what are we doing? Product rule. Good, because it's function times a function. Function times a function. So we're going to do the product rule. Okay, do it up. Derivative of the first. Always take the derivative of the first thing you see. The derivative of secant is, do you remember? Secant tangent. And then times the second, just because it comes along for the ride, plus the first times the derivative of the second. Yep, and it's negative. Now, I'm going to get to the point where we're working our negative signs over a little bit better. So I'm just going to put this negative sign in front so I don't lose it. And that is cosecant cotangent. All right, now look at this mess here. What do secant, cosecant, tangent, and cotangent all have in common? Yeah, we could rewrite those in terms of sine and cosine, right? Do you remember back in your trig days when you wanted to simplify stuff, you put it in terms of sine and cosine? So let's do that right now. This is 1 over cosine. This is sine over cosine. And this is 1 over sine. Minus 1 over cosine, 1 over sine, and cosine over sine, right? Now let's simplify these fractions. The sine on top cancels. Over here, these cosines cancel. So I'm actually, I'm actually left with 1 over cosine squared minus 1 over sine squared. And how can you rewrite those? Yep, secant squared minus cosecant squared. Good. It's nice just to clean that up a little bit. Have it to where it's easier to look at and it's a nice clean answer. So here's the other thing about trig. Yes, you have those memorization, but trig is prerequisite information. I have uploaded in the course that formula sheet for trig. You can use it as a reference to help you recall, but are you going to have anything for the exams? No. So if you don't know them, learn them.